masses. So both masses cancels out, and we get that V is the square root of 2G L1 minus cosine theta. And that's it. We found V. Once we found V, we come here, we plug it in. Again, it's the use of momentum for the collision, and any other topic, you have to remember the previous topics that we learned in physics. Energy can solve the problem. Example. Look at the study guide. And I give examples on the study guide . So, similar, problem related to this, to the ballistic pendulum, will be problem number 4. They can state differently, not necessarily, this is the general theory. Problem number 4. Problem number 6. Problem number 9. Problem number 10. That's it. So you solve the problem related to the ballistic pendulum. Let's take, for instance, and look, question number 1, or sorry, 4, 6, 9, and 10. 4, 6, 9, and 10 are related to ballistic pendulum. For instance, let's say, number 6. A 10-gram bullet moving at 1,000 meters per second tries and passes through a 2-kilogram block initially at rest. In this case, the two blocks stick together? No, transpass. It's different, but it's the same idea. The bullet emerged from the block with a speed of 400 meters per second. They give the speed of the bullet after. The question is, to what maximum height will the block rise above its initial position? At the beginning, what is happening, or what topic we have to refer to in order to apply it here? When the bullet hit the block, collision, conservation of momentum. Then the block will go from the lowest level to the highest level. What topic? Energy or free fall? If you want to use free fall, you can use free fall. I prefer to use energy. Okay, so what will be the equation at the beginning? How will look the equation at the beginning? Pi equal to P final. Let's say what is Pi. I want to see what is Pi. I know that is Pi is equal to P final. Law of conservation, because there is collision. But what is Pi? Who has momentum at the beginning? It's the momentum of the bullet and the momentum of the block at the beginning. Tell me what will be the formula for the momentum of the bullet.
Mass of the bullet.
And mass of the bullet, which I label N1, times the velocity of the bullet, which they label V. So if they label V, you can label the V after, V prime. But we label this U1, correct? N1 U1 plus what is the momentum of the block Remember that is the total momentum. What is the momentum of the block before the collision? 0, no momentum. So we have the same thing, N1, U1. Can you see that we have the same thing? Equal. At the end, we don't have the combined momentum. Why? Because transpass the block. So we have to have the sum of both momentum. What is the momentum of the bullet? How can we label? M times V prime or N times V. If you label U, the V that they gave, you can label U and then you can label V. That's up to you. M of the bullet times V of the bullet, which is given? Given. Plus what? M of the block times N2 times what? V2. On that equation you have there, check what you have and what you don't have. Everything except V2. We need to find V2. What do we use in order to find V2? The conservation of energy of what? Because we need just V2 and they are separated. The bullet is in one direction or whatever and the block is in the other direction. We want to care about the conservation of energy of what? The block. And what is the initial energy of the block? Initial energy of the block after the collision. If at the beginning doesn't have energy, cannot rise. Kinetic. And what will be the kinetic energy? So we will use EI is equal final. What is EI?
M plus M.
No, they didn't stick together. They don't move as an assembly in this case. You need to look at every situation is different. So in this case, the bullet went one way, and the block. We are caring about the energy of the block. At the beginning, you told me kinetic energy, 1/2 mv squared. At the end, M2GY. Can you find? You have Y? Do you have Y? The elevation of the block. That's what we are looking for.
Yeah.
Since in the first equation of momentum we can get V2, right? Because that's the only thing unknown. V2, we will use that V2 in the second equation of energy and we can find the height. Yeah.
At the moment when the bullet hit the block starts moving before the bullets transpass, right?
Not necessarily. I mean, we are assuming that it's very instantly. You know, when the block will start moving, you know, that the transpass, we don't care about the dimension. This is a model. You have there, so we can, but that will be more complicated, the problem. We imagine that transpass instantly. You understand what I mean? Otherwise, if we complicate, if this way is complicated for many students, physics, imagine that we keep complicating, putting things that, you know, like we don't simplify. This is a simplified version of reality, which is what we call model in physics. We use model to simplify, because otherwise it will be very difficult to find things. All right, so did you see the application of energy and momentum together? Let's look at problem 9 and look at the situation. We have a 3 kilogram mass that is sliding on a horizontal frictionless surface, like a ramp, with a speed of 3 meters per second. When it collides with a 1 kilogram mass initially at rest, the masses stick together and slide up a frictionless circular track of radius 0.40 meters. The question: to what maximum height h above the horizontal surface will the masses slide? At the beginning, what will be?
CI
Hmm?